Okay, well, now we have the right deck. That'll even be better. So Paul asked us to do this. This is a decoder and also a what the heck is actually happening coming up for this year. Now, of course, the thing's already out of date, right, Dion? So
Yeah.
you just have to remember, this is basically January 31st, 2024. I think we'll probably have to do this update like quarterly or something. Don't you think? Things are just happening so quickly in this world. But as usual, we are going to um, try to summarize the unsummarizable. Right. So I just want to comment that this is part of a multi-part series. So we also have a section on history and intuitions. This is really for people who don't know too much about AI, like me, with starting this whole thing out. This part is really about the decoder ring, which are all these terms. I mean, Dion, there's so many terms to understand in this thing. It's like a whole new language. And then trying to do some predictions. We actually are going to do eventually a section that's just a pure practicum. So Dion, you know, and I know this, but we have a T&E studio that we have that makes a lot of this easier. And so we'll hopefully show a little bit of that soon. There you go. So first, I want to issue a full apology. There's just such a blizzard. I mean, Dion, every day it doesn't seem like we have a zillion things we have to learn and talk about.
Yeah, it's really a fire hose of new information
Yeah, yeah,
almost weekly. Yeah.
yeah. And I actually did a chart. I went back over the last 20 years and looked at Archive, which is the big computer science collection mechanism on the web. And this chart actually shows the number of papers done every month for the past year. What do you notice about this thing? There's I mean, oh my God. They're basically in 2015, when the whole thing started, we had a huge inflection. The first week of January, I did the countdown, 1,300 papers right after New Year's. I mean, it's crazy. Now, I just want to contrast that in 2004, 20 years ago, the total number of papers published on Archive was 1,000. We're doing more in a week than people were doing in an entire year. Now, most of the things are boring and useless papers. I mean, just so you know, but just you know, how much time do we spend just going through papers trying to figure out what's useful? I mean, it's crazy.
Yeah, in the beginning it was quite daunting, but after a while, if you do it long enough, you kind of learn which papers are high quality, which universities you should follow, which you should ignore, because there is still a lot of noise in that signal,
Yeah,
but it's still a fire hose, and you can get lost quite easily in it. That is true.
yeah, and that's really what we're doing, which is pointing out that just sheer absorption is becoming a real problem. And there's only a small number of organizations that really can keep up with this stuff. And one of our contributions, I guess, to the community is we're trying to help everyone keep up.
Mm.
Now, the thing is that at the highest level, this on the right is the classic Gartner chart. And they actually every year chart where technologies are on what they call the Valley of Disappointment. So on the left, you sort of see technologies that are very mature, right? Oh, sorry, they're just beginning, like GitOps and so forth. And then you sort of expectations rise and rise and rise and rise. And then inevitably, there's 2 to 4 years of complete disappointment, right? By the way, you know, generative AI is right at the top of this valley of disappointment. And I think the point is that it's a lot like 1999 with the web or 1864 with the railroads, where there's a huge boom. Things didn't really make any money for the investors initially, but it really changed America. And so I think the AI investment is very similar. It's staggering how much money we're going to talk about, like billions of dollars. Dion, did you hear that Sam Altman wants to raise $7 trillion for his next fund? That was like beyond insane. So basically, I think the main message is creating a new platform. You don't need to get to artificial general intelligence to be useful. There's a lot of things that will be super useful in time. And ultimately, the idea that our entire 4D world, you know, 3D plus time is going to get integrated into compute, that could actually really happen within our lifetimes. I mean, we're seeing all the indications that computers can understand and act in the real world. And in many ways, the point of this presentation is hopefully we're on a different curve. I think everyone is down to the red curve of disappointment, hopefully we can create a much softer landing, right, Dion? So people aren't disappointed by all this stuff because that's brutal to have
Yeah.
2 to 5 years of disappointment.
Yeah.
And we've all been in industries like where the hope was great and then we failed. So let's try not to let that happen. So let's just get into the predictions. Um, when we started this deal, I remember we were trying to predict for like a decade, and then it became a year. Now I feel like, I mean, how good is this predictive accuracy really?
Mm.
You know?
Yeah, no, it's hard to predict.
Yeah, yeah, it's really hard to predict. So don't take this too seriously, anyone listening. This is just our view. So what we're going to cover is 8 diamonds in the rough, and there are seven technical things that we're going to cover, and then one about the industry and customers. We're just going to go through each phase of these things because you have to have some way to chunk this stuff out. And the first one is, everyone's talking a lot about chatbots, but this idea that this really could be an emerging operating system, I think, is one of the most important concepts that we have. And Dion, I think, was it Paul who created this term, Saint Andrew? I think, but
Yeah.
Andrej Karpathy, who's one of the great thinkers in this era, tweeted back in November this point, which is, I don't think it's accurate to think of a large language model as a chatbot. It is a lot more correct to think of it as the kernel process of an emerging operating system. And I think don't you think we've really taken this to the full fruition? In other words, thinking about these things as really just a kernel.
Yeah, no, indeed, because it has all of the hallmarks of a kernel forming a much larger computational system.
Yeah, yeah. And so when we think about what we are doing at the Neural Enterprise, it's really to instantiate that. And Dion, you came up with this diagram, which I really love, which is how to think about not a large language model, but think about the large language model like the kernel, and there's all these other pieces you need to make this work. And there's a lot of good analogies here. You can think about the kernel like a CPU, as Andrew did. You can think about what's called the context of the input buffers like RAM, and you can think about weights like firmware because they can be traded, but you have to have a lot of I/O too. And I think what we've learned, Dion, is that you just can't park a file up against a large language model. That just doesn't work at all.
Yeah.
Yeah. So the thing that you'll be seeing is us going through what's changing in the core in the AI expert, what's happening on input, what's happening on output, and then what's happening in terms of actually making the operating system. So I think the first step is you can really think about these things as, sorry, just a little bad slide transition. You can think about these things, and you notice we have AI experts parked here, right? And I think one of the things we've learned is that you can't just think about this as, I'm just going to have a single large language model doing everything. And I want to give you great credit, Dion, for realizing, helping us realize that it's really about, you have to have a RAG expert, you have to have a code expert, you have to have a SQL expert, and they all have their own embeddings and weights. Don't you think that, that's really the way we've been constructing these, don't you think?
Yeah, indeed. And it makes a lot of sense because, well, from a product perspective, it's more flexible to have like more of a microkernel approach than going monolithic. So, given the space that's changing so rapidly, you need a lot of flexibility in your backend architecture so you can swap out individual components. And if you're stuck to only one large language model that does everything, well, first up, there's a lot of research showing that it's really a Swiss Army knife in the limit that it's great at a bunch of things, but it's never really an expert in any one of them. Plus, there's risk of single vendor lock-in, and if you get displaced by another language model, it can really disrupt your whole architecture.
Yeah, absolutely. So I think the way we've been thinking about it is you got to construct a sort of a custom network of experts as opposed to thinking about it as just a single expert.
Yeah, and this is different than the mixture of experts architecture. This
Yeah.
you can see this as like a collaborative expert architecture.
Yeah.
And in principle, I guess it's very similar to what a mixture of expert does, but you just have way more flexibility. You can actually swap out the experts, where with a mixture of experts architecture, you can't because it's still bundled into one large language model.
That's right. And other interesting thing is that once you have these experts, you can actually have a series of specifications, and then you can actually tune the experts themselves. So it's sort of experts all the way down. And we've done a bunch of work on, well, if you had this system, how would you make it better by essentially retraining each thing and fine tuning everything? So it's been a really exciting expedition. So I think the overall forecast we have right now is the large language model this year is really about massive refinement and customer focus. And I think you can see the refinement, which we're going to cover in a second. Large language models are getting better. The open source models, Dion, I think have gotten a lot better in this short time frame, don't you think?
Yeah, they have improved quite a lot. There's really a lot going on there. Llama 3 is going to be released pretty soon. Even like the Llama 2 models from Meta has been doing a pretty good job. And what we found is if you use a bunch of smaller, fine-tuned domain-specific models and put them together in the right way, you can be at the same performance quality as the latest GPT-4 model,
Yeah,
for example, at a fraction of the price,
yeah,
which is really exciting. Plus, you've got all of the flexibility in the back end to keep on, moving to newer models as they're released.
yep. And then I think the second thing we're seeing is just that IO revolution, basically taking multimodal data like vision, sound, images, and also output. So generative AI is really coming of age too. Sora was just announced even after this, which is the open AI generative model, but you're going to see a lot. And then I'm really excited about this idea that you can just read a website or computer screens. So there's a lot of work going on understanding things that computers generate, which basically means that without much work, you can get a computer to read all the things that we know how to read. And of course, the big one, Dion, with your background in robotics, I just think the robotic thing is just taking off like crazy, don't you?
There's a lot of interesting things happening there with robotics transformers, when folks are going directly from image input to robot commands via the LLM, without going through any type of translation layer, which is, really exciting. I mean, there's obviously a ton of safety critical things to think about there,
Right.
but it is really exciting just to see the pace at
Oh,
which this has been developed in the last couple of
it's
months to weeks, I want to say.
it feels like every day there's another advance where this idea of a large scale model that understands things is really happening. But I think the cautionary thing, of course, is there is going to be a lot of AI disappointment because what's actually happening in the world on the left is it's really hard for customers to figure out how it works. And I think the thing we need to realize is information flow is super low because this is a complete change in technology. And what we think is trivial is actually a massive um, advance for most people. We have a WhatsApp group of 50 or 60 people now. And don't you think it's interesting, Dion, how we're reading papers and people are going, but what is a large language model anyway? I mean, the diffusion thing is very low.
Hmm.
Yeah. And I also think, and we've seen so many cases where what we call the try or rejector problem, where there's a semi-useful AI, people try it and it's not that useful. I mean, I do this all the time. I'm so excited about this new app, and then I try it and it doesn't really work. And then you're like, ugh, it's crap, right?
Hmm.
So one of the things you're going to see us focused on a lot in our little company is doing less, but doing less by doing more, because the world loves things that where you do a tiny thing well. So instead of trying to like do a full AI expert system, maybe just make a report work better. And people are very happy about that. So it's a much more gradual thing. I think the fourth thing is, asking customers to write specs is really hard. So like it's always like, can you just solve this problem for me? And we don't you think we spend a lot of time just trying to figure out what the requirements are, figuring out a small thing to do and make it better. Yeah,
Yeah.
huge advance. So let's just go into the first thing, which is the kernel, which is, and I always say this, it's raining large language models. I mean, don't you think there's like one every minute these days?
Yeah, it sure feels like it.
It's so crazy. And by the way, it is true. There is a massive explosion. This chart shows all the only major large language models. So considered significant in the industry. Since 2018, there have been 252 highly significant large language model shipping. Just think about that,
Mm.
Dan. I mean, normally you get one innovation, you're getting millions of innovations and gigantic new parts of the tree that are opening up.
Yeah, and even the chart is still out of date with it doesn't have Sora, doesn't have
Yeah,
Grok, and it doesn't have a bunch of others that folks will already know about by now. But that just speaks to how quickly the space is
yeah,
moving.
yeah. And if you want to date it, just doing retrospective of 2023, it felt like the first half of 2023 was like parameter wars. You know, GPT has 1.8 trillion parameters. Oh, okay, I can top that. I've got this many parameters. And then everyone's starting to enter the business. So Llama, of course, shipped the first version with 13 billion, 34 billion, and 70 billion. So a lot less than 1.8 trillion. Google Palm had 540 billion. Anthropic had 93 billion. And then the second half was everyone's in the pool. Like everyone announced Claude V2 shipped, Gemini Pro shipped, Gemini Ultra shipped, Mistral shipped, Perplexity shipped. It's just crazy. Now, here's the depressing part. That's not even the most significant part of the explosion. Because if you just take Llama's open source model, which Meta shipped, I checked, by the way, in January. I'm sure there are more now. But as of January 31st, there were 16,000 open source variants of Llama. Just think about that.
Yeah.
Just paging through it's really important, really hard. The table on the right just shows some of the major variants. And what people are doing is they're tuning them for specific uses: math, finance, education, medicine, law, every language, human language in the world, every type of machine. This has been one of the most incredible things because Llama's open source. I think it's changed our world, don't you think, Dion? Having this open source available.
Yeah, no, for sure. It really makes things a lot easier. And the open source models are pretty good. I mean, and you don't need um like a super high parameter count. I think it was the Chinchilla paper that first came up with
Yeah.
with that nugget of insight. But no, the open source push has really been very good. Especially from a company perspective, so you don't suffer from either single vendor lock-in, but we've also seen the models like the OpenAI models being improved because of what the open
Yeah.
source guys are doing, because they want to stay ahead. So competition just improves everything across the board.
And I got to give a shout out to my very favorite Reddit group of all time, which is Local Llama. And this, I think, is a very significant development. Everyone thinks these things need to run in gigantic computers. You need to spend $1 billion. But you're using a lot of these models on your desktop, right?
That's right. Using Ollama. So I'm on a Mac, and I have quite a lot of memory on my machine. So I
You
can
make
also
me crazy jealous by the size of your computer.
Yeah, with LM chat, you can run like a 70 billion parameter model pretty comfortably on a M3 Max. I would say it's still a little bit slower, but there's a lot of techniques coming down the pipe to improve inference speed with things like VLLM and the like. So it's just going to get better.
Yeah. And what this means is it's taking the cost of development way, way, way down. So instead of
Mm.
having to have a cloud and all this hooked up, we're headed towards a world where you can do very rapid development in your local environment. And it's interesting. I did the stats. So they have 105,000 members on this thing that was created like last year. It's in the top 5% of all Reddits already. So you can see there's a lot of developer interest in these kind of open models, running it on your own machine, and harnessing that's a big deal.
It's actually part of our normal development cycle at T&E is we first look at leaderboards such as this one that's on the slide right now. But we don't just look at a leaderboard and then pull the model into production. That's way too risky. So we do a lot of local development on the desktop using things like Olama, but mostly LM Chat because LM Chat LM Studio, sorry. LM Studio also allows you to run a little hosting server.
Yeah, it's
So
great.
you can do a lot of quick and dirty testing and run your own local benchmarks before you even have to put anything in the cloud. It's
Yeah,
really
it's
useful.
super useful. And I think one of your comment is really accurate because this is a leaderboard that's done by LMSys. It's an open source company, and this was the way it was June 31st. And the way this works is the number, which is like 1211 for GPT-4, or Claude V1, which is Anthropic's product, which is 1169. What this means is actual humans look at the output of these two models and say which one's better, right? So instead of these kind of benchmarks, you can always, as having in my past life, not to say people would, but you can always game a benchmark because you know exactly what it is and you can tune it forward. These are just regular humans looking at random output. This works like a chess score. So 1200 is like a really good chess player. And so differences of about 15 points are not significant. But what happens is if like Claude V1 beats GPT-4, its ELO rating rises a little bit and GPT-4 shrinks a little bit. So it's a good way to think about the competition. And the big thing you see as of last year in 2023, essentially your only choices were closed source models, right? So GPT-4 was at 1200, Claude V1 and Claude Instant V1 from Anthropic were in that range, and then GPT-5 Turbo was right up there. And then really the open source models like Vicuna, MPT, Guanaco, they were really significantly lower at below 1100. Now, there was big money here, right? Because Mistral started with $1 billion valuation, got $250 million just to be in this world. And so when we started this whole project, remember Paul would say, I think it's going to be a long time until open source ever catches up. But a miracle happened, which was called Llama V2, which Meta open sourced, and the tables changed quite a bit. Let's take a look at that. So on January 2020, January 20th of this year, I circled for you all the models above 1100. Quite a few more, don't you think, Dion?
Yeah, it's a massive improvement.
Yeah. Now, if you look at it, GPT-4, which is rumored to be require 160 gigabytes of VRAM, right? Just contemplate that for a second, right? So this has to run on devices with 30 or 40 that cost $30 to $40,000. Still retains their lead, but you can see that Anthropic and Mistral, which Mistral shipped, is really catching up. So the GPTs are still running ahead, but you can see Mistral Medium and Claude V1 are at 1158, 1148. But you see this thing called Mixtral. This is one of the tricks. Mixtral is the open source version of Mistral. And they open source that. It's got 8 separate large language models that work together in that mixture of vectors which you talked about, Dion. And boy, the performance is pretty good. 1124 versus 1131 for Claude. So that's a huge change. And then, of course, Google, you can never count those guys out. They did a beta of Gemini Pro, which is their latest model, and it's right up in there, 1121. So it's just been a huge shift in the way we want to think about these things. I want to point out the Chinese, this is YiChat, is not far behind at 1100. And there's just a huge collection of these models that are available that have very high performance. Last thing, though, I wanted to point out is you got to grab some popcorn because 10 days after that, so that was January 20th, 2023, January 30th, oh my God, Google arrives and their models got even better and better. So here you can see Gemini Pro with the developer API is actually now beating GPT 3.5 Turbo. So literally, I feel like every time I look at this, it's like grab some popcorn, something else has changed. So these things are not stable at all. Things are always changing. Dion, you mentioned Llama V3, which is coming out, and they said they've got 350,000 H100 graphic card equivalents, which, by the way to think about that is a graphics card costs about $40,000, and the complete data center around one of these graphics cards costs you about $1 million. So they're talking about billions and billions of dollars, and they've ordered another 250 million H100s. I think V3's when is V3 coming out now, Dion?
There's no hard date yet, but Zuckerberg announced it pretty recently. So I can't imagine it's going to take long after the announcement, but
Yeah,
there's no date as far as I know.
yeah. I think the rumor is maybe in June and so forth, but definitely this year. I mean, they're going to do something for
Yeah, it's a
sure.
June, July rumor.
Yeah,
Yeah.
yeah. So grab some popcorn, guys. It's going to get even more crazy. Now, it's one of the things I want to point out is that it's not just the quality of the models that matters. It also matters how fast and how small they are. Now, smaller models, and what this chart shows on the left is the training time for these models by the number of parameters. And what you see is the standard curve. A smaller model takes a lot less time to train. So Llama V17B, which is way here in the lower left, took about has a performance in the range of about 60 on this benchmark and took about 100,000 GPU hours. But Llama V2 70 billion took 1.75 million GPU hours and its score is slightly higher. So there's a real trade-off between getting a small model and the amount of training you need. So our interest is in trying to find the smallest model that does the job, right? You don't always want to park a Mack truck if you're going to go get some things from the Safeway. And one of the things I really like about what you're doing, Dion, at TNE is you're finding the right model for the job, right? The second thing is that there's also a trade-off. Smaller models can be much smaller and run much faster. So this is a little bit of a busy chart on the left, but it basically shows the size of the model by the circle, and then its throughput. So higher is better on the left, and then how well it does in terms of scoring on a particular benchmark. So as an example, if you can get the Cerebras GPT 1.3 billion parameter model to work, and it's good enough for your situation, it can run at over 70 tokens per second, right? Compared to Llama, which is running at 20. But more importantly, the size of it is the memory footprint. That thing can run in a consumer class GPU. Whereas these big models require a gigantic H100 to run. So the cost really goes down. And some of these models you can even run on a desktop, as we've talked about before, or even just in the CPU, which would reduce your computational cost dramatically. So it's not just about getting the best model, it's getting the right size model so you can get it to run faster.
Yeah. Yeah.
Yeah. Also, tuning makes a big difference. So this actually chart just shows looking at Mixtral, and it shows that just by doing some tuning, you can be significantly better. So in this particular benchmark, the standard Mistral bench product was running about 72 points for this benchmark. Someone on the open source community then tuned it up and made it run better, and they got it to 77, which would be state of the art. And you can see a cloudy Mistral 70B is at 73. So this is a good example where a very big model that's 74 billion parameters only performs marginally better than the 7 billion parameter models, which means it'll be much faster. So these kind of trade-offs make a big deal. So you can't just say, oh, I use ChatGPT. That doesn't mean that much. You have to be really specific about what you're using where. Now, we have some very specific models like for SQL generation, right, Dion, that are much smaller and much more efficient.
Exactly. And what you can see here, like when they fine-tuned the 7 billion parameter models, but it's a mixture of expert architecture with only two models that has a significant increase in performance over 7 billion parameter models without the further fine-tuning step. So, and that's what we've seen. It's actually one of the lessons we've learned, one of the mistakes we've made early on, is to think that we need to select the most powerful model and then use that in, you just wrap different code around it and use it in different applications. And this might be old news for most people out there today, but when we started off in the beginning, what was that, 8, 9 months ago, it wasn't that clear. We thought the bigger the model, the better the model, that's the one that that's the horse you need to back. But we've really learned that using these smaller fine-tuned models in these specific verticals is way more efficient from a cost and inference point of view than going for the larger models.
Exactly. I want to just go through a sort of fun example for those of you who are in America, because even the big models perform very differently. And what I'm going to show you is a bunch of queries that we ran during the Super Bowl, which was back in January 24th or so of last year, of this year, and see how different models perform. So this basically shows that tuning really matters. So on the left, you see one query that was run against GPT-4, and the second is a query that was run against Bing at exactly the same time. And even though they're both using GPT-4 underneath, the responses are actually quite different. So I'm just going to read this to you. I asked, what is the score in the playoffs for Kansas City, and will they win the Super Bowl? Which, by the way, they did. Hooray. But it says, first of all, GPT says, I'm currently having technical difficulties accessing real-time information. This is a very common problem that when you're running things in the cloud, sometimes it doesn't work. I asked again, and it basically says the Chiefs achieved a good victory, et cetera, et cetera. It doesn't give anything specific about why they might win or lose. Look at the thing on the right. This is exactly the same query run against Bing. It's quite different. It's much more specific. It, for instance, says the City Chiefs have won all 3 of their games in the playoffs, including their most recent victory against the Ravens. And you see this annotation thing here, Dion? It actually shows you exactly where the data came from. So even though it's using the same model, the way it's tuned is quite different. And you can see it very specifically gives a money line score for whether they're going to win or lose, because it's actually looking at specific data on the internet. So even though it's the same large language model, the way it's tuned and the data it looks at makes the responses completely different. So bad news for everybody. Evaluation is very important when you're doing this. I wanted to show you. Yeah.
Really good point. It's the tuning, and it's also the way they vectorize the data. In other words, the way they ingest and manage the data going into the large language model. That coupled with tuning, it can lead to completely different results, even if you use the same underlying LLM.
Yeah, yeah. Not all V8 engines in a car are created alike, and not all cars, even though they all have 4 wheels, are the same. The interesting thing was we then took it and used 2 models that have been shown not to be as good as GPT-4 in those benchmarks. And the specific ones here are, you're going to see Bard on the left. This is using, it's actually been renamed to Gemini, but it's using the internal Gemini Pro model. And then Perplexity, which is a startup that's just using Llama v3. So they should be terrible, right? We know from all these benchmarks, they should be terrible, but let's look. So on the left is the Bard query. And what it says is, it actually has real-time data. So this was during the game and it said, the Kansas City Chiefs are currently doing well in the playoffs. They just won the AFC divisional round game. This literally happened 1 minute after the game closed. So it has exact real-time data on game stoppages or game fixers. And they said it gives the exact score with a score of 7-0 and headed to the AFC championship game. And then it gives you much different formulation. It actually tells you exactly why it thinks the Chiefs might do well. And it explains about the defensive play, which, by the way, they did a great job. It names various people. And then it actually goes down and says, overall, they have a good position to win, and gives a full set of websites that it used. So very different than GPT-4 and very informative. Now, Perplexity should be the big loser here because it's only using a Llama v2 model. Here's what it says. The current score of the game is not provided in the search, so it doesn't have that. And it recommends checking a reliable sports and news app. So it actually gives you a decent recommendation. But then it focuses in on the second thing, which is what are the odds they will win the Super Bowl? It actually does a very good job. It says the Kansas City Chiefs currently have odds ranging from plus 325 to plus 50. It actually does some math. It says the probability of winning is probably between 20 and 23.5% of going all the way to the Super Bowl and winning with full data source. So I don't know about you, Dion. I think Perplexity is doing pretty well, even though their quote unquote LLM is worse.
Yeah, definitely.
And so a lot of this is about that magic of tuning and having that specific domain. I'm sure there is a sports focused model. Maybe we should go build one, Dion, that would do a great job on like football, the Premier League. They'll be highly tuned for it. So you got to really look at the corpus and the data sets before you talk about the LLM. Okay, let's talk about the second thing. I'm going to just say this is deep stuff. So please feel free to move on if you don't want to see it. But this is really about what's going on inside the LLM internals. One of the ways to think about it is, LLMs are essentially a bunch of text in and a bunch of text out. And there's a bunch of components. And we're going to talk about the front end, which is how embeddings are done, how buffers done, and there's the most important thing about attention, which is how you know what inside a gigantic million line thing, how you know what you're supposed to pay attention to. The original paper was called Attention is All You Need. And I'm amazed at how much work has gone into making attention really work well. And that's been going to be a big area of innovation. It was in 2023, and it will be this coming year. So one of the ways to think about this is that it's all about the context buffer. So one of the ways to think about this is that, in essence, if you look at GPT-2 and you ask, well, what is really going on in the system? What you'll find is all this multiplication, all of this work, all this attention is essentially a lot of matrix math, and it's got to fit in some very specific places in the system. So the way most GPUs work is they have a big GPU, right? And they have a small amount of static RAM, usually about 20 megabytes. And then they've got onboard RAM, which is about 40 gigabytes or so. And then there's main memory, which is over a terabyte. And a lot of what all this attention stuff is about is how do I get the right pieces of data in the right places? And one of the things that, and this shows with traditional large language models, this shows the amount of time it takes to do computation. And all of this stuff, dropout, soft masking, and masking, all of this, if it's run only in static RAM, can be much faster. And that's this technology called flash attention. So flash attention basically takes all this computation, figures out what to stuff into the static RAM, and it becomes much faster. The other things that are happening is trying to make this static RAM, picking out the right pieces in the context buffer to put there. Because when you have a million tokens in, you've got to pay a lot of attention to what you're actually putting into the system. So you're going to hear about a lot of things about flash attention, approximate attention, hierarchical attention. And it's just the simple idea that you want to get as much stuffed into the system as possible. We today have tried these million token things, and it just works sort of semi-well. So the engineering to get the right things in the right place at the right time still are very important. Now, there's a big movement beyond these attention things. You're going to hear about something called Mamba and also striped hyena. These are some of the major techniques to improve inference. So the chart on the right, this uses something called Mamba. It's inspired by flash attention, but basically it's a much faster way to figure out what's important. And the interesting thing is, Mamba 2.8 is about 5 times faster than a traditional model, but it also works across 1 million tokens. Now, I did the math. 1 million tokens, Dion, is more words than you and I will speak in a year. So 1 million tokens is a lot of data. The interesting thing is, if you take a small transformer model, the thing on the right shows you the performance of these things. And in red is the performance of a traditional transformer against the 1 million tokens. And you see basically it's impossibly small. It's like 40 or 50 tokens. This is the latest data on the Mamba paper. They are doing inferences at the rate of over 1,000 tokens per second, right? That means that you could basically summarize 1 million things, more than I've ever spoken in a year, and generate a complete document out in literally half a second. So this is a tremendous change in the way we do things. You can see, by the way, that kind of improvement is going to be very important, because most of these models, you know how they sort of type with like teletype text with those chatbots? That's because they're running really slow, right, Dion? I mean, you know, when you're running 20, 30 tokens, I mean, it takes 10 seconds to generate 300 words. I mean, we've seen this, that's really hard to get snappy user interfaces with those kinds of systems. Yeah.
Yeah, the Mamba paper, when that came out with the Mamba model, it was really, it's really innovative. It's really something new, you know, moving a little bit away from everyone just trying to get either more parameters trained or, you know, fine tuning things. This was really a great innovation that happened very recently.
Yeah. And I think now it turns out Mamba in detail is not a true transformer. It uses something different, but people are trying to apply those same type of things against traditional transformers. So there's this thing cleverly named striped hyena, which basically, Dion, you would appreciate this. It uses digital signal processing to predict which word is most important in that 1 million token buffer. So it actually treats the words like a signal. And the result is it's much more efficient than traditional Llama 2. So the charts on the right essentially show the performance of these kinds of models, which are basically 10 to 20 times more efficient than traditional attention models. What does that mean for all of us? That means that we can stuff a lot of stuff into that context buffer, into RAM, than ever before. We started this whole thing back in 2023 that you could only stick in 4,000 words in essence before it overflowed on the buffer. Now we're up to 100,000, a million. It's really changed things a lot. So the second thing we'll talk about is what's actually happening inside the machine, which has to do with the actual architecture, e.g. how you do the math and how weights are generated. So I won't go through in a lot of depth here, but there are a lot of different architectures for how large language models are created. In its essence, it's about whether or not how you look ahead and look backwards. And the short thing here, you can read this later in the notes, is decoder-only architecture is really one. And what a decoder architecture means is, in essence, it does very little processing of all the tokens beforehand. It really doesn't look at any prior tokens. It basically, in essence, only predicts from the past, which turns out to be much faster. But the thing that's been a big change, and Dion talked about this, is the move from a single monolithic model to really a mixture of experts. Dion, maybe you want to explain what a mixture of experts is for our listeners.
Sure. So instead of having a single model that's trained up, a single monolithic model, there's normally between 2 to 8. I haven't really seen more than 8 models under the hood. Of course, we don't know really what's happening with the OpenAI models, but the rumor is that it's also a mixture of experts architecture where there's, I believe, 8 models, each having 175 billion parameters. And then there's a gating function that basically decides which of the network gets used given the input context. So, this is much more processor efficient, and it's nearly identical in performance as compared to using a single model. But it's still one baked in model. So from a user perspective, it still feels like a single model, but there's a dispatching and a waiting function between that just routes the user query to the appropriate expert model under the hood.
Yeah, this thing should really
They're also typically fine-tuned with LoRa and these types of adapters to get these individual experts fine-tuned for their specific tasks. So you can have one that's good at coding and one that's good at instruction following and one that's good at chatting, for example, and then combine them up.
Yeah, I think for this should really be called mixture of LLMs, not a mixture of experts, but it's that exact idea, which is you can conceptually think of expert 2 as knowing everything about Taylor Swift you've ever wanted to know. And if you're not asking a question about Taylor Swift, the network basically shuts down and you don't need to have it in memory. But if you're curious about SQL, then expert 1 may turn on. And there's a gating network that learns how to mix those things together. So it's a very powerful idea, and it's I think probably the future of all models, don't you think, Dion? Everything's going to become a mixture.
I think so, because it just makes so much more sense. It's also cheaper to maintain the model downstream because you don't have to retrain a massive model with billions of parameters. You just train individual experts under the hood of your model. You can keep the other ones pretty much unchanged. So I think this is probably the way forward. Unless a new architecture drops in 5 seconds, then it's going to be a different story.
The paper's probably already been published that changed everything. Even in this call, I did the math, by the way, in the time we're doing this presentation, essentially 100 new papers have shipped. So we're already behind, Dion, even in this conversation. Just to emphasize Dion's point, no one knows how many models there are running, but it's also clear computationally, getting beyond 70 to 200 billion parameters in a single model is just super expensive because you have to stick so much VRAM into the system that it's just not practical. And the proof, by the way, the rumors have varied about whether GPT-4 is 8 or 16, but it's something in that range. And no one knows, because they don't publish these things anymore, what GPT-4 Turbo is. But the rumor is that it's a single 200 billion parameter model. Mistral is 8, as you said. There's a rumor that Mistral might actually be 32, which would be groundbreaking, to put 32 models all together. But again, all these closed source models, no one's published anything. I think I'm looking forward to the first mixture of experts open source model. That will tell us a lot about how these things perform. Yeah.
Yeah, I'm looking to Meta to be the first ones to release that. I wouldn't be surprised if there's a mixture of experts architecture released with Llama 3.
Oh, actually, I hadn't thought. That's a really good point. That's probably how they have to do it. Yeah. So that would be great because we're going to have 16,000 variants that are open source that we can study.
It's the only logical thing that makes sense to me because, they don't have magically like more data.
Yeah.
So how would you improve over Llama 2 to Llama 3? The only thing that really makes sense is going mixture of experts because there's no new architecture unless they adopted the Mamba type architecture that I can also
Yeah.
see.
Yeah.
But maybe I'm just quietly hoping, I'm quietly rooting for a mixture of experts from Llama
But,
3.
okay.
Yeah.
You got two of us rooting for it. Okay. Now we're going to switch to the next part in terms of extending input. This is the other big innovation inside these models. And you may have heard of retrieval augmented generation, vector graphs, and knowledge graphs. And this is basically when you have a huge data set of billions of words, how do you figure out what to stuff into the input, into the RAM? And so you can think about this like a caching. Here's a disk drive. Tell me what I'm going to put inside of it. So, Dion, why don't you explain just for people who aren't in the field, what is RAG and what is knowledge graphs, just so people have a sort of a general sense.
So where RAG comes in is like what Rich just mentioned. There's a finite context buffer. So there's a finite amount of text that you can put into a language model. And so how do you handle the case where you have more text than what the language model can handle? So in that case, let's say you've got a bunch of PDF documents that the model hasn't been trained on. So it's inside your company. It's a bunch of, let's say, maintenance manuals on aircraft engines. And you would like to build a system where users can interact with these manuals digitally. So the expensive route would be to go and train a large language model on these PDFs. But a faster, more cost-efficient way would be to change all of the text from the PDFs into tokens and then put that into a vector database. It's just a special database that works really well with LLMs that can then be used. So if there's an incoming query from the user, the vector database just provides you the relevant chunks of text that's related to that user query. And then that goes into the input buffer. So we've gone a couple of steps further along these lines. So we also do things like, when a user asks a question, the question might be ambiguous. And the question also is often related to the conversation history. So we will take the entire conversation history and also put that into a vector database. And that allows us to take the user query and expand it into something that makes more sense given the conversation history. And then that just gives us a much better chance of extracting the highest quality, most relevant information from the vector database before we put it into our large language model. And a knowledge graph, um, they play pretty well with the RAG systems, and this is just a way of basically organizing the knowledge. Once you've extracted it from your vector database and you want to build relationships between concepts, then a knowledge graph works pretty well, where you can kind of cluster topics together that makes sense, and then there's a relationship between these topics. So this is all technology to help the LLM to give it a better chance of providing higher quality output, essentially. Without this, we found that the
Yeah.
output from the LLM can be
Yeah.
quite
It's
low and
terrible.
sometimes even unusable in certain
Yeah.
cases.
Yeah. So I think this is the case where there's a lot of fine tuning. Understanding this is a very complex area, but it is a big area of innovation right now. Thanks, Dion. Now, you can actually extend this to a lot of different things. So this extending input thing has gone crazy. So accessing the internet, existing SQL databases, enterprise system, and running any code. That's become, I think, sort of the cutting edge. And probably the most interesting thing that's happening is, in essence, feeding back the output of a large language model to itself. So it can actually learn and do planning and so forth. So this idea that you can actually have it give it an overall big task, and then it can divide it down and keep running, creates that feedback loop where it's just talking to itself.
Hmm.
So one thing that to realize is there are a bunch of standards for this. So OpenAI, and this is a little bit confusing. OpenAI created a plugin architecture, and a lot of people think that it's proprietary to OpenAI. It's not. It's just basically a set of standards for how you call things, and it's open source. There's back in January there were 1,039 different ways to access data that was available, and this is everything from how do you get to a Yelp database or a reservation system, and they don't do anything useful with themselves, but they are really a domain-specific language that explains the syntax, how you write code and do things. Now, the simplest form that you see a lot is something that generates Python or SQL, sends it to the plugin, you feed back the error message, you change the code, and you try again. We've been using that a lot, haven't we, Dion?
Yeah, that's right. We have been using these plugins quite a lot. On our side, we're of course using Satoshi's /GPT project. And I guess we'll get to that in a second, but it's very similar idea. And also getting back to RAG, RAG is also just another plugin to the
Yeah,
system, but that's a plugin that actually gives the LLM memory that can change over time, and that's essentially a fine-tuning mechanism that's much more cost-effective than retraining the foundational model.
exactly. And the whole, as you said, the whole thing about planning agents, I think is really, we think this year is really on the way to understanding how to make these things work effectively. Basically, the idea is instead of having human generate prompts and get an input, the computer sort of processes it itself. It's like an LLM is like a snake eating itself. I get some input and I feed it back to myself. Now, it's really difficult to control. There are a lot of experimentation. There's a technology called chain of thought, which basically, just you add the word step by step, and it basically does it. There's tree of thought where it does searches, and there's all these strategies for doing things. And there's really a contest, I think, between these procedural systems and having LLMs constantly reformulate and rerun input. Baby GPT, Auto GPT, these are all systems that you have very little control over what they're doing, and you sort of watch them do their work. Okay. Now, here's the amazing thing. It's not just text anymore. So ChatGPT, for instance, has the ability to add input where you can actually load a JPEG file in. And the way to think about it is in front of it, there's actually another large language model that converts all that text, all those images into a text stream. So for instance, it might say, hey, there's a boat here at location 2312. There's a sneaker over here at 2 and 4. So it turns into text, the actual images. And then you'll hear a lot about diffusion models. It actually is the reverse. You send it text, like I want a video of a 10-story hotel with a laughing crowd, and it will generate the corresponding image. And so the whole idea of a large language model, and I think the great simplifying assumption is to realize what it's really doing is, for it, everything is a text thing. So it doesn't read JPEGs. It doesn't read images. It reads the textual descriptions of them. Right? Now, the systems can actually be quite complicated. So for instance, there is image to text systems that in essence take text, and this is GPT-4. They in essence take the image, they convert the image into a collection of features, and then figures out and then sends it over there. So in this particular case, you might have a visual representation, an image encoder, right? And then it sticks it inside a large language model. The large language model then writes the photo that it wants to see, and then uses another large language model to generate the output. Comments, Dion? So it's in some ways it's very simple, the idea, and it's kind of amazing that it works. Yeah. So in the example below, this is actually in the notes. This is an open source project where the person just said, "Here are all pictures of pizzas," and then you can write a quote, which is, "Please give me a wild boar pappardelle with this chunk," and actually will generate an image that looks like it. So this whole idea that you can actually train it on images and now produce images like it is a very powerful idea. And that is really coming to fore in this period. So let's move on to the next one. Sorry, hang on. You can apply it to more things. You can apply it not just to text input, but to text output. So this is like diffusion and large language models have a baby and meet each other. I don't know if any of these are going to show up. I always wonder when these things, but you can actually do this for video. So Sora, we mentioned, just happened, which is very high quality, but there's a lot of open source work. So at the top, you'll see something called Emu. Let's see if we can get this to run. So this basically is a open source image generator that said, please make a video of a dog with a kite in the back. It doesn't look too bad. It also allows you, again, in open source, to say things like, please make an edit. So you can actually take an existing image, read it in, and say, and then set my Aperol spritzer in a pool. So here it is. So you add the text orange juice, it adds orange juice. Then you can say, make it a spritzer, and it makes it a spritzer. So you're just adding, you're just chaining prompts. And you can say, remove the text, it removes the text. And you can say, set it in a pool, and it regenerated so it's in the pool. So this idea, you can take a large language model, it can actually drive image output. I think it's going to be pretty big and pretty important, don't you, Dion?
Yeah, like I don't think we fully grasp where this is gonna go yet. I mean, like simple use cases you can see in the gaming industry. I'm seeing a lot of folks looking at this technology to build open world games where the NPCs are driven by large language models, and a lot of the artwork and texturing is done with diffusion models. But I think that's only the very, very, very beginning. This is really incredible. Also, if you look at just how the video generation has improved in the last couple of months, it's quite staggering.
Yeah, yeah. And there have been a lot of projects, for instance, the one on the right. I don't know if this works. Can you guys hear this? Do you guys hear the music? It actually,
no.
Okay, well, it actually is playing a song because we asked for a teddy bear in a leather jacket and baseball club playing the guitar in front of a waterfall, and it actually plays synthesized music. So they're combining video and sound together. The thing on the lower left, I think, is even more significant. This is an open source project that does tuning optimization. It runs at over 120 frames per second on a consumer GPU generating images. So this is the real-time output saying, please generate cats, please generate cats. And so you can see the performance improvements have been dramatic as well. So a lot happening here. And I can't wait to make a video game where I just say, make a cool video game and give me $1 billion for my video game. That's going to be the prompt I'm going to use. Okay, next one. Okay, the next thing that's happening is Screen I/O. So in this particular case, we are already seeing the first devices that are actually fully large language model compatible. So there's a technology called CACT, for instance, which actually which takes the image recognizer and then applies it to web pages. So the system can read any web page. Rabbit Tech, Humane, they're all doing these.
I'm taking an early look at the Rabbit
user
R1,
interface
and
only
this
systems
device
that only use voice.
Doesn't have any apps on it, but it.
So that idea that you can actually just have systems that just do Screen I/O that can interact directly is, I think, one of the big trends that are happening.
And on this,
I'm taking an
yesterday or
early
the day
look.
before yesterday, Deutsche Telekom, which owns T-Mobile here in Europe, announced a project where they want to work with they're developing a mobile phone that has a fully neural interface. So it's very similar to Rabbit, but it's a smartphone that they want to release. I'm not sure if they're actually going to do it, but it was released in the news literally a day or two ago. So
I think we're going to see a lot of, I would say 2024, we're going to see a lot of experiments, don't you think, Dion, on these all native interfaces where there's no screens at all. Yeah. Okay. Nearest and dearest to our hearts here at the Neural Enterprise is 3D and 4D worlds. You can extend the idea to just let's push in a full world where instead of getting the dog is at 324, you get a full 4D coordinate. Like there's a dog behind the cart at location 343, 320, 343 at time 1 minute and 43 seconds in the video. Or here's Excel and here's what it is and here is the size of it. So a true, real understanding of the world. And then you can imagine on the output to a robot might be, oh, move there and go clean the room, or click on that menu and choose a file. that is going to be very exciting when we can finally connect, if you will, the brain to the real world. I think it's coming, Dion. What do you think?
It's definitely coming, and it's interesting to see like how the technology has evolved because they started off with neural radiance fields and then quickly moved to 3D Gaussian splatting. And then all of a sudden, you saw a lot of folks working, especially on Google side and DeepMind, on navigating through these 3D worlds. And it just makes it so much easier because, you can augment that with LiDAR, of course, and other types of data sources. But having a contextual understanding of the 3D world just makes so much sense for so many of these use cases.
Yeah, we'll cover this in the sort of the first quarter 24 update, but there's been a lot of work now that changes the actual embeddings for large language models from text to actual images and video objects. So just train the model directly on the videos. And I think it's a very exciting area that could really yield some great fruit. This example should be near and dear to your heart, Dion. So this is what we were working on last year. Remember this project? Maybe you can explain what it is.
Yeah, so for this project, we actually flew a drone, a mini swarm of drones fully autonomously through a construction yard. And then with less than 200 images, we could create this 3D model. But calling this a 3D model actually doesn't really do it justice. It looks like a 3D model, but it's much more. So less than 200 images goes in and the neural network is trained up. And then it basically does novel view synthesis. And that's what you're seeing here when we play the video. We actually query the model to provide us a visual output given a certain XYZ and pose orientation. So the camera has never been at this specific location, but the model understands the scene and then gives you exactly what that scene should look like from this perspective. And we've tested this. It's geometrically accurate. There's no distortions. There's no skewing. Because in this particular use case, we had to compare what the model gave us against construction blueprints.
Yep.
And this is the neural radiance fields that we talked about, which blew our minds when it came out.
But then,
and then it became obsolete.
But the new technology is even more amazing. As Dion mentioned, Gaussian splatting is promising. It's 6 months later, showing you can do real-time training of the model at over 100 frames per second, right? So you can actually produce these things. This particular neural network model that we trained took about 10 minutes to train. This Gaussian splatting technology looks like it's actually real-time, right?
And that's really needed because neural radiance fields, we've tried a couple of times to get it to work with virtual reality technology, but it's not there yet because it's still quite heavy to run. Like to run a neural radiance field model, you need pretty hefty compute, you need cloud GPUs. Whereas with the Gaussian splatting technology, it seems like pretty soon it can run on just commercial grade, consumer grade desktops and laptops. And the biggest advantage of the Gaussian splatting thing, in my view, is it also captures physics, like physics-based behavior. And you can set the model up. So I've seen examples where folks did a model of a tree that's blowing in the wind, which is super useful because it just gives you so much more realistic and immersive 3D scenes that can be used for, obviously a variety of applications.
Yep.
It's much better. There's a big step up from nerves for sure.
Yep. So we predict that this year there'll be a lot more work in that area. There's already a lot of work on monocular depth estimation. So from a single camera estimating depth, and this is a case where Apple, with their we're not allowed to call it Apple AR, it's Apple Spatial Computing, but this idea that you can actually generate a full 3D model from an iPhone 15 Pro at 1080p, 30 frames per second is pretty exciting. The last thing that we don't have time to show is you can actually directly integrate a large language model to this. So the readout here is like this image, but it can also say there's a ladder to the right, there's this thing to the left. So it's actually direct textual readout of the objects in the system. But pretty cool. Okay. And I guess we'll just go show that quickly. So, Dion, why don't you go through this, the integration of a 4D world to a large language model?
Yeah, so this is a LERF it's called, but it's essentially, as what Rich is saying there, it's a combination of a large language model and a neural radiance field model. And in this case, you can literally ask it questions. You can ask it, show me the stairs. You can ask it to read text. It can pick up text pretty well. But what we found is if you've got, let's say, a warehouse that you've scanned and you want to see if there's any broken boxes on the shelves, then you can ask it for that, and it can tell you these boxes are broken and these boxes are not broken, for example. Pretty powerful. It handles reflections really well. We've done some examples of where the objects of interest are behind glass, for example, and it can see straight through the glass and detect and tell you, here's X amount of Powerade bottles on the in fridge, for example, in a grocery store scenario. So really powerful. I haven't seen the Gaussian splatting community doing anything in this direction yet. There's LangSplat.
Yeah.
I don't know if you've seen more around LangSplat, Rich.
Well, our prediction is that we're going to see a lot more of LangSplat and other variants like this because it's so important for robotics. And, big startups are being funded right now, and they fundamentally have to understand the 4D world immediately. So the prediction is we're going to see a lot of research development. I don't know if we'll see practical products, Dion. I'm not sure about that. We're going to see a lot of research work, don't you think, this year?
Yeah. No, I do see that. I do see that. And hopefully some integration with ROS so we can start testing it with our own robots.
Yeah.
It would be fun.
Now, the output side is just as interesting. So actually, DeepMind launched something called RT2. And the basic idea is on the left, you can actually just say, please close the bottom drawer. And it knows enough to generate the robot instructions to do it or knock a Coke bottle over. So I think there's going to be a lot of work here, those so-called language action models, where basically you take it, you're not programming it in the traditional sense, you're giving it intent and it figures out what to do next. And so this technology called RT2, Sarah, which is basically a way to work on the input side. AutoRT is basically, for those of you who are science fiction fans, implements the please don't kill my kid when you're trying to open the Coke bottle kind of technology. So it does things that aren't bad for humans. And then Trajectory tells you can actually learn from a video the robotic commands that are necessary to duplicate what the human did. So there's a company that was just announced yesterday called Figure that just raised money at $1 billion valuation that's productizing these ideas. But again, we think this is going to start, the large language models showed the way last year. The 4D thing is working this year. And then what's going to happen maybe in the next few years is putting it all together to create a complete robotic operating system. I can't wait. Yeah. It'll be great. What could possibly go wrong, Dion?
I'm going to lock my Roomba up in the garage.
Yeah, you definitely want to do that. Yeah. Okay, I'm just going to, those are the big magic shows. I'm going to go quickly through this because we're running a little long because Dion and I like talking about this stuff. But we're going to talk about how training is done. Training is one of the most important things. I think, after all this, training and tuning, this is one of the key parts about getting a model to work. It's not like you can just take a factory, fresh from the factory, large language model and have it work in the real world. No. Right? That doesn't work at all. So one of the ways to think about this is, by the way, I have to comment, the literature here is a dog's breakfast of different terms. So everyone's using different terms from things. So for the purposes of this talk, we'll just use, sort of general terms that apply. But the way to think about it is the training happens in 4 steps. First, there's a pre-training step, which takes a general corpus of knowledge and gives the basic training. The way to think about this is it's enough to teach a student like how English works, or there are people. It's like the very basic high school stuff. Then there's a very important step called alignment, which is basically to make sure that what it produces is actually acceptable for humans, right? Because a lot of times the stuff won't be quite right. Now, the interesting thing about these 2 steps is, and I think, Dion, you mentioned this, a lot of commoditization here because the general corpus doesn't really change. The general corpus of how the world works is not changing substantially, right? What is changing is the details. And that's what this fine tuning step is about, which is typically private training data. Like, this is the way my spreadsheets work in my company, or this is the way that I want my robots to behave. And that step is typically done with what's called soft prompting. And so what this basically means is the models are so general now, and the context buffers are so large, and embeddings are so powerful. A lot of times you can do very, very cheap fine tuning just by putting different prompts into the context buffer or changing the embeddings. And that's a very important branch of optimization, because it doesn't mean you have to spend $30 million retraining the whole model. You can take the existing models and just sort of lightly train them. Then the fourth step is optimization, which is these models are huge. They use floating point, 32-bit floating point. Optimization basically takes the machine specifications and says, let's shrink the weights down so the thing runs much more small. We've almost reached the limit here, Dion, right? We went from 32-bit floating point to 16-bit floating point to 16-bit integers, and now we're down to 1.58 bits.
Yep. Yeah, this was very recent development, but indeed, it still blows my mind that you can train the model using 64, double precision variables, essentially, and then you just take the number and shove it into like a 16-bit integer, dropping all the precision, and the model performs like over 90% to the original performance scores. It was a really interesting innovation when that happened.
That last year was one of the big things. And part of the reason for that is, if you look at the pre-training, having the hardware and data matter a lot, because a typical 1,000 GPU system costs $1 billion to build. Let's just grok that for a second. So avoiding this, if you're in a little startup and you don't happen to have your dad be a billionaire to give you $1 billion, it'd be much better not to avoid this. So just to give some examples, GPT-3 took 1,000 A100s, 700 gigabytes of VRAM. I don't even want to contemplate how much memory that cost. 34 days. GPT-4 is probably 10 to 25,000 A100s, right? Falcon B was 384 A100s. The list just goes on. Inflection was 3,500 H100s. That's a $3.5 billion data center just to train it. Meta, as we said, has 250 going to 650. I just want to say how big a change this is. The biggest research labs like Harvard has about 144 GPUs going to 528. Stanford has about 700. So the big guys have 10 to 100x more. And the hosting costs are very significant, right? So GPU hosting costs all in are about $1.52 to $2 an hour. CPU hosting cost equivalent is about 0.02 cents. Think about that for a second. And that's why utilization of these GPUs is so important. What happened last year was a huge push towards better utilization. So there's this thing called NeMo Megatron, which basically increased the utilization in the GPUs by 30%. So the training days went from 34 to 24, and 4x reduction in VRAM. Now, I want to comment here, inference is completely different. Inference, which basically is not training, is much more fundamentally tuned around the amount of VRAM you use, and there's a lot of technologies for making those better. The last point is that data, you are what you eat. This is a list of how different models are trained. Today, by the way, essentially no one's talking about how they're training things because of all the copyright issues. Because if you say I'm being trained on the New York Times corpus, the New York Times is going to show up and say, you owe me money for that. Okay, next thing that's a little complicated is alignment. And so this in some ways is an even bigger barrier, because you need humans to, in essence, look at the output and then say what's better or worse. The most famous thing here is called reinforcement learning with human feedback, which really came to the fore last year. And that's basically, given a prompt and an answer, humans rank which one's better or not. And then you train another large language model. You train the model to say, here's what I should pick. So it's a way to basically train a model on a model. Supervised fine-tuning basically takes human label data and then looks at the prompt. And there's a bunch of other techniques all the way down to reinforcement learning with AI feedback, which is in essence that you use a large language model that generates similar responses to train the big model. So sort of large language models all the way down. Comments, Dion?
No, I was just thinking in all of this, and Nvidia is laughing all the way to the bank, but you can see that in their stock price.
Yeah, yeah. It's helpful to grow your revenues 30% a quarter as everyone tries to build these things out.
Yeah.
Now, I think the main thing to do is if you don't happen to have 1,000 GPUs handy, there is a really big gold rush for all the rest of us. I don't think anyone in this chat should get the impression, well, if I don't have 1,000 GPUs and $1 billion, I can't get anywhere. Because the fact is, there's even more innovation on fine tuning than there is in model training. And essentially, this is a relatively complex graph, but it shows the three major ways that you can adapt, that you can fine tune the existing models. There are adapters, which are essentially taking small pieces of it, adding things. So there's a collection where you add different basically matrices to the model. There's something called selective, where you basically get rid of things. And there's reparameterization, which basically means you're actually changing the weights. And then there's soft prompting, which means you're actually filling the context buffer with the tuning that you want. And all three are valid techniques. And I think it's probably like a paper every day about how to do this better. There's LoRa, QLoRa, and so forth. So we think that there's going to be a lot of work going on to take an existing Llama V2 or V3 model or mixed straw model and make it as performant as a proprietary model, but have it run at 1/10 the cost. Because that's super exciting for us. So we're spending a lot of time there. So I just want to make one comment about soft prompting, which is sort of the unsung hero of all this. So soft prompting has sort of got a bit of a bad name. It's called prompt engineering sometimes. It's sort of the hacking thing. But the basic learning here is that you can take a soft prompted model, and what you see on the chart on the right is all these techniques for soft prompting. And one is called few shot. And this is the simple idea that you just give it a couple examples and then you teach it. And then you have multiple shots, you have training. And the basic lesson here is that you can get to just as high performance with these kinds of prompt tuning designs as you can with full model tuning. So in the upper right, the upper bars are things that were done with full model tuning. So very expensive with GPUs using QLoRa and so forth. The green are things that are just done by being smart about the soft prompting. And you can see essentially get to the same performance. So this is an important result that you can basically take a model, do prompt tuning, and then later on change the prompting, get to that same level of performance. And then what we normally do is then we go back and fine tune the model so you get a very small one. So it's a good way to get good tuning very quickly when you're doing prototyping.
That's right. I mean, with LoRa fine tuning, we found with internal testing, you only have to fine tune around like 1.4 to 1.5% of the model weights. But the drawback there is you still have to fine tune it. So it's not that dynamic.
Yeah.
And for our production systems, we prefer more something what we like to call it's like dynamic in-shot tuning. So there you can combine a vector database that has all of the tuning examples in, and dynamically on the fly while it's running in production, you can fine tune the system. So there's no downtime. You just update the instructions basically in your database store, and then you can fine tune on the fly.
Yeah.
Gives us pretty good results. Equal, in my opinion, sometimes better than what you would get with LoRa, depending on how you do the soft prompt tuning.
Yeah. And I think where we're headed is we'll do the soft prompt tuning to get the thing running. And then once we have something that's stable, right, if it doesn't need dynamic retraining, then we can apply LoRa to it.
Yeah.
Yeah. So that leads us to what's all this then about LoRa? So this is the full reparameterization, right? So you're actually changing the model. And what this chart shows is if you go and let's take SQL generation as an example, but this on the left, oops, sorry, my bad. I'm in hell. Here. Okay, so what this chart shows is on the left, on the right is how GPT-4 performs against things like converting something into JSON or SQL generation or doing math. And you can see it's quite good, right? The small little bars below are taking Llama 7B and 13B without any training and seeing how they perform. And you can see they're pretty terrible, right? So the 7B model, which is tiny compared to the GPT-4 is really just bad, right? But if you do the reparameterization, which basically means you take the data set and you retrain, this is changing everything, you can actually get the performance that's actually exceeding GPT-4. So this just takes the specific data set like SQL and says, I want you to only be good at SQL. And you can see you get reparameterized models that, even though they're 7B, much smaller, they're just as good. And in some cases, like with JSON, it actually ends up being much better. And in some cases, like math, it ends up being worse. So it is kind of dependent, but you can get dramatic performance improvements.
Mm.
Now, the interesting thing is if you then do something called LoRa, which basically means that you're not changing every parameter. As Dion says, you're only changing a small number that really matter. Here are some of the results you get. So this actually shows that same curve. The thing on the left, this is just using SQL, and it shows on the left, this is the performance of the llama without any tuning. This is the performance with full parameter, and this is actually the performance with just LoRa. Now, LoRa, what that means is you decompose the matrix and you find the places in the math that where it makes the most difference, if you will, and you only work on those small pieces. Because in a gigantic model, it turns out only a small part of the matrix actually matters. So look at this, Dion. You're getting performance better than GPT-4, and the model tuning is very quick and fast. Because LoRa is also very fast to tune, right?
Yeah.
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 So instead of taking days, you can actually do this in an afternoon and get high performance. So the path of doing soft prompting to get tuning, then using things like LoRa when the thing is solid to get high performance is really the way that a lot of us can get models that are just as good or even better than GPT-4, but at very minimal cost. That means a lot of money for us, right, Dion?
That's right.
Yep, we like that. I just want to give an example of how some of these things work. I should point out that closed source models do allow this kind of fine tuning, but the problem is when you have a closed source model, you can't really change the weights, and so it's not really clear what they're doing. So, for instance, with GPT-4, with Azure version of GPT-4, you basically feed it a bunch of examples, and these are some examples on the right. Like my role is the system, my context is Marv. Here's my user context, and then it runs through a black box training method to improve it. And you can see why most people are doing open source fine tuning. As you know, Dion, we don't even know what they're doing. Right? We just get a black box out that says this is supposed to be better. We don't know what actually happened. We can't really train it. So this is an example where open source should have a big advantage. And you can see all the people are trying to say they're going to be able to do fine tuning because it's so important. But I think everyone's struggling in the closed source community with how to provide that same level of flexibility as the open source models. And now let's talk about optimization. So this is, you fine tune the model. Can you make it run smaller? Now there's a bunch of different techniques here. Distillation, which basically means you have a big model teach a smaller model. There's pruning to get rid of model weights that don't matter. But I think the greatest of these is actually this quantization thing, don't you, Dion? That seems to have the most traction. Maybe you can explain what it is. This is actually from my own machine that shows in a mixtral 8.7b model how the sizes can be different.
Yeah, so this is a very interesting technique where the foundation, let's say the base model, is trained in the classical way, and each of the model weights would be stored in a high precision variable. So let's say typically a double precision floating point number, so 64 bits. That's the biggest you can get. So that gives you the highest amount of accuracy. But then what they do is they literally just take the number from that highly accurate variable and just pack it into something else, like a 16-bit integer, for example. So they drop everything after the decimal, and lo and behold, the performance is still more than 90% of what you would get with the proper model. And that's really interesting. And this allows you to run it on any, like, not any laptop today, but you can run it on a MacBook Pro at least. And if you have enough VRAM, like even on a desktop with an NVIDIA RTX card, I think if you just have at least like 16 gigabytes of memory, you can run quite a number of models.
Yeah.
So
Yeah.
this has been really, really impressive to see. I didn't expect this to work at all until I started testing it and saw I was really surprised.
Yeah. Yeah. And just to show you the advantages, it's not just running on the desktop. It means you can run in a tiny machine in the cloud, right? I don't need to have a H100. I can have a small machine that's highly performant and much cheaper.
You can run it on a smartphone potentially as well. I think a lot of these smaller models nowadays can actually run on an iPhone.
Yeah. Well, that's the big drive, is to have the inference running in a phone. And I think we'll see a lot of that coming. Diamond number 5 it's been called in-context learning. It's been called prompt engineering. It's called planning, but it's really just still programming. And so I thought I'd just show you how we think about that problem. And one of the ways to think about it is we use a tool called /GPT that was developed by our chairman, Satoshi, to basically to help. And what it lets you do is it lets you divide, if you will, the programming of the system into various components. And it helps you sort of summarize, it gives you a much better set of tools for if you will, putting into the context buffer the right thing in RAM. And there's 2 ways to think about this. The first is there's a planning agent, which basically is, what are my business processes? How do I work? What's my help? And then there's fine tuning on things like vocabulary and templates and rules. These are all very important things to get done. And /GPT has been a great tool for us, don't you think, Dion?
Oh yeah, it's really sped up development quite a lot because it's just so well architected. The model is abstracted with a simple manifest file that's in a YAML format.
Yeah.
So what it really saved us is on writing a lot of code. We're still a small team, and nothing. I'm not. I don't want to say anything negative about frameworks like Llama Index or LangChain, but when we started this journey, those frameworks weren't good enough for us to use yet. It was too early. So I'm very glad that Satoshi built /GPT, and we've standardized our entire architecture really on top of that framework.
Yeah, and it's important because there is a complete mess of tools. This is just a chart showing the major tools and all their functionality, and it is really hard to get through all these tools and understand them. I wanted to give a little impression about why we're thinking about this, and this is, maybe way technical. You can skip through it, but here's the problem. This is using LangChain, and this is typical code that you would see. And one of the problems is it's a mix of a lot of different libraries. There's a lot of sort of setup code, and then there's just a lot of text strings, right? So for instance, this is, here's my top prompt template, and here's some more work. So it's sort of a mixture of text, and it's a mixture of code, and you can see there's a lot of libraries you have to load. So it's very hard to figure out what's going on. And this is sort of the maintainability problem. Now let's contrast this with another way to, by the way, this is exactly the same approach. This is a different kind of approach where you're basically using what he called a manifest. And the idea here is separate all the Python code out and just create a simple file that explains what's going. So you're sort of extracting all the strings out. So in this particular case, if you feed the file on the top, it's a neural expert, smart home expert, you can tell it what model you're running. You can say, here's my prompt, here's my form. The section below is, here are the functions that I can call. And so this basically informs the system so you don't have that kind of spaghetti code. Another example would be Llama Index, which we also talked about. And it sort of has a similar idea in that, but it does have a lot of these connectors. So there's sort of simple directory read, directory store index, and so forth, which you can also represent just as a label. So you can just have a model there. So this idea of having a full manifest approach is one of the things that I think is turning out to be very maintainable for us. And I just wanted to show you this example. So this is something called DSpy, which is a planning agent. And here's the actual DSpy code on the left, which generates a Q&A. And it says, please open this, find this output, please run it with these parameters, please load my data set, make a chain of thought, et cetera, et cetera. This is exactly the same code, but done as a manifest file. And you can see already how much easier it is to read. It says, run this, here, run hot Q&A, here are the procedures, and so forth. So this is we find that the code on the right is much easier to read and maintain because it's basically a textual representation of the same thing that's written in Python. Comments, Dion?
No, none of this. It's just, like I said, it just makes it so much easier, not only to maintain, but to read. And like we just spoke earlier around how you need to be flexible on the architecture side to adapt these, new models as and when they appear. And just imagine having to rewrite a lot of code, refactor a lot of code if you're depending on writing Python code for your backend. But abstracting it with these manifest files is literally zero code we have to write. We just update the manifest file and we have access to a new model in the back end, which is really nice.
Yeah. And again, it's models all the way down. I just thought I'd show you this for fun. So that YAML file that you saw, I actually just asked our system to say, convert the code into a parameterized YAML file, write a Python program to parse this YAML file and run it. So this is actually all the code you need to run that YAML file. Right. So it's very easy to take anything that is code and convert it into these YAML representations that I think will last for a long time. Okay, planning agents. This is this hard problem about what you should do next. I think the big summary of this is there's no real winner yet. So there's task decomposition, there's multi-plan selection, there's external aided, there's reflection where you look at it, there's using a RAG to store things. And the punchline is, just if you look at this chart, what it shows is that with nothing, you just start on this hot pot Q&A, you have a 1% success rate. If you just add a little bit of data, so a few shot example, it goes to 30.32. If you do all the complex stuff, it gets to 0.38. So there's very little advantage right now to using these complex planning agents. I think that will also change this year. People are going to spend a lot of time on this planning agent work.
Yeah.
So watch that space. I'm not going to cover this in great detail, but Julian in our little group said, but you got to talk about the hardware too, man. So decoder ring number 6 is about the hardware. So this is a quick sort of IT level explanation of what's going on with hardware that partially explains why NVIDIA is worth so much money and why you should avoid some of the expensive stuff and use cheap stuff instead. So in this particular case, you can look at this chart later. It essentially shows why hardware is such a huge business. So at the top is the estimated GPU data center share for NVIDIA. It's over 94%, and it's going to stay that way for a long time. And on the bottom is the cost structure comparing a CPU to a GPU. The punchline is the rental cost for a typical CPU system is about 0.6 cents per hour. The cost for a GPU is about 1,000 times more at $1.50. And if you go through all the numbers, the big difference here is the top one. A typical CPU server costs $15,000. A typical GPU server costs $350,000. This was your point, Dion, about all the money that NVIDIA is making. Right? That's where it all is. It turns out all the rest costs more, but it's really about the GPUs. Now, if you take a look at what's actually happening, there are a lot of people trying to compete with NVIDIA. So there is, on the development level, MRock, PyTorch 2, OpenAI Triton. But the big problem is all of the work that NVIDIA has, the so-called CUDA layer, that basically makes, that's all that everything's tuned for. So even though an AMD MI300X is theoretically 30% more powerful, in benchmarks, it doesn't really matter that much because of the tuning. The second point to make is, it's not just the GPU, but they actually have a world-leading advantage in how you connect the GPUs together. So for instance, NVLink, which is their format, is currently running at 900 gigabytes per second. And the open source standards are running about 64 gigabytes per second. So it's just a huge difference in performance that basically lets them very quickly integrate huge systems together. And as you've seen with these large language models, you need lots of GPUs hooked together to make them work. Now, the big change, though, is at the edge, the world is almost completely reversed. So this is, Dion, this is your MacBook Pro 3, MacBook Pro with the M3 chip. And you can see when they started benchmarking, it was about 45 milliseconds versus an NVIDIA CUDA system that was running about 3.5. The orange bars are M1 Mac, M2 Mac is in purple, and then in red is the M3 Mac. And you can see the performance differences have really shrunk. And the reason for that is most of the performance in inference is actually in RAM performance, getting all the models in and out. It turns out Android phones, iPhones, MacBooks, they have a lot of energy directed towards putting essentially the RAM on the same package as the GPU. So it's a very fast interface. So this is why I think we can expect to see this year a lot of things running just on desktops and mobile phones. There's a tremendous amount of innovation with local tools, Apple MLX, Google Gemini Nano. I think you're going to see a lot of inference on phone class devices very quickly. Pretty excited about that, aren't you? It'll be great.
Yeah, I know it's going to be it's going to change a lot of things.
Yeah. Diamond number 7 is the one that I think is probably the biggest diamond in the rough and where there's so much money to be made, which is in safety and operations. We can't let large language models go crazy. And the fact is, there are a lot of problems here. And it's a little bit to me like the problems with antivirus or with all of these fake things, which is it's the number one issue for most customers. And it's the one thing that we as technological people don't spend a lot of time on. And it's very hard because you have to have, and I think this taxonomy is quite good. You have to have the assurance that the thing that you just developed actually meets the spec. You have to have security because people are going to try to hack at it. You have to align it to make sure that it's not doing evil things. And then you have to consider the ethical implications of some of the things you're doing. There are already some big startups in this area, but the elephants in the corner are deep fakes. You can't tell the difference between a video and a non-video. Elections are happening everywhere and fake news. There are some big startups like Calypso AI that's just raising for data layer security, Hidden Layer, Lakera. They're all important innovations in the area of safety. Yeah. So we have more. We're actually working on a lot of things that we're not ready to talk about in this area, but huge area that it requires real thinking. But just the assurance problem is quite difficult. Okay, Dion, we're almost done. We just have to talk about customers and we're done. Okay, customers. I can summarize this very easily. It is really like the tale of two cities. This, by the way, is generated. We eat our own dog food by image generation package. So on the left half, you have this industry mud wrestling to be the very best. And on the right, it's like we live in tech heaven with all these cars and real world customers have no idea what to do. And the number of bridges between them is very low. And half the bridges look like the one on below. They don't actually lead to anywhere. So this bridging is really, really important. By the way, I'll send you the prompts if you're interested in how we got this to work. Okay, so let's talk about what's happening. We have OpenAI, Microsoft, Meta, Perplexity, and Hugging Face. We've got the big market leaders. We've got the big open source community. And then we've got the near contenders. And then we have people catching up. And I think I'd summarize this by saying OpenAI is the one everyone's looking at, and Microsoft's got all their weight. But at least in our view, that open source community, I don't know, Dion. I mean, we're both Linux fans. You can't ever count those guys out, do you think?
Yeah, and especially given who's behind it. I mean, the biggest open source push is from Meta, of all companies. And I mean, the quality is looking really great. And then Google is catching up. Eventually, Bard initially was pretty crappy, but with Gemini Pro, I mean, like we've seen earlier on some of the leaderboards, it's not only caught up, it's actually one of the main contenders. And it's still anyone's race. I
totally
can't
agree.
make a bet to tell you which one is going to be the best a year from now. It's impossible for me to say.
Yeah, I think our prediction for this year is no prediction. We don't know.
Yeah.
But building a system that is very flexible, that can switch back and forth, is going to be very important. There's another thing happening, though, which I think is good for all startups, which is there's a race to the bottom for the so-called large language models as a service. So when OpenAI launched, the pricing structure was basically for 1 million input tokens, we would charge $1 and $2 for 1 million output tokens. The current price for that is it's completely free. So Mistral launched and it was $65 and $1.96. Then Fireworks launched, it was 40 cents per 1 million and $1.60. Then Together launched, it was 60 cents output only. Perplexity is 1/10 the cost of input for OpenAI. Anyscale is free input, 50 cents output, and so forth. There's even a project called Open Router that will dynamically look at your queries and figure out which is the cheapest and then run it for you. So I would advise everyone on this call to use other venture capitalist money wisely, because people are spending billions to provide these services for free. I also want to remind you, you can always roll your own. And it turns out that if you just assume 11% debt, you can actually build a nice H100 system if you can get it for very little money. So it's very possible to build these things yourself. Now, the break-even point depends a lot on the quantization. So we talked about quantization before. The trick with a lot of these scalers is they're actually heavily quantizing the models. So they're much cheaper to run than the full 32-bit thing. And what it basically shows, this chart is a little bit of an eye chart, basically shows that the cost per million tokens at around 8-bit integers with a batch size of 2, now I'm going to explain that in a second, is basically cost competitive with the big OpenAI infrastructures. And what that means is batch size is related to the problem that when you crank up these models, you want to run a lot of queries before you kick the thing out of memory. And so batch size says, how many multiple queries can I run against the same thing? One of the problems, one of the advantages the big hyperscalers have is they've got a lot of customers. So they can sort of fill the queue up. If I want to run the big model, I'll fill it up with 256 queries, do all that math, and then kick it out again. If you're a small one, you might only have 2 queries running. Then you got to load all the stuff in and load it all out again. So this sort of how much you can batch things, that's a very important factor in this race to the bottom. Put another way, it might make sense for you to use Perplexity as a backend because they're aggregating all your queries against a lot of other small startups, and then their cost is much lower because they're amortizing that big H100 against 250 startups instead of just one. So this is one of the things you have to watch carefully, and we watch carefully the market for LLMs as a service.
Yeah, that's right. Even though we have a full ML ops pipeline, we host our own open source models, but it just doesn't make sense to host your own open source models if you can get it from some of these other providers at basically for free, because then you don't have to pay for the GPUs yourself. That's a very important point.
Yeah, this is
I think a lot of startups skip over that. They either only use OpenAI or they only self-host, but there is a sweet spot in between.
Yeah. And again, I think the prediction for 2024 is being dynamic. Dion, I love the way you've developed it. So we can be all large language models as a service. We can be partially that. We can be partially running our own internal models. And we can just dynamically change those things based on what's happening. So it's super, super great. I want to comment that it's an absolute sea of new entrants. I mean, there are so many companies that are just AI companies. This just shows what's happening at the foundational level, the data level, the level of prompts, the level of observability and manageability. So there's a lot of things happening. Now, in the end game, which is, I think it's always interesting to think about, you can definitely see Microsoft and OpenAI wanting to be the Microsoft and OpenAI of the world. And you can see OpenAI wanting to be the Microsoft of the world. And you can see Google focusing on protecting their core foundational search asset. But I think even in this last quarter, I think they've become much more aggressive, don't you think, Dion? I mean, they've open sourced the model. I mean, it's been amazing.
Yeah, definitely. Definitely. But where do you see Apple in all of this? Because, they're definitely making a play in this area. There's dedicated neural chips in their hardware. Although, they're not really focused on data centers. I mean, you can see they want to run these things on the edge, but I don't know yet where I'm placing Apple in all of this. What do you think?
It's one of the reasons I didn't put Apple in the end game speculation, because I don't know. I mean, my guess is they're certainly very focused on it, and they're going to do a really good job on inference performance on MacBooks and iPhones, because that's clearly where Google's headed as well. Whether they'll have a big role in the open source community or contribute or be more like OpenAI, I don't know. I think their heritage is totally closed. Don't tell anybody anything. But it would be great to have another Meta-like company out there that's really fueling the open source world. Now, there is an antecedent for this, which is, of course, all their operating systems are based on a BSD variant called Darwin. So they have been taking things in and out of the open source community for a long time. I'm kind of hoping that they're going to take a more Meta-like position, which is, in essence, the open source community is so big, we want to be part of that community so we can suck modules in. Because in their current incarnation, for instance, if there's a new QLoRa or a new flash attention that's based on Llama, they have to re-engineer their entire thing to use it. Whereas if they did something open source, then they could just use it immediately. So I'm hoping that they do the best of both worlds, which is great products for us consumers, but actually join the open source community like Meta has, so that the community gets much better. Because anyone who's below the level of several $billion for a data center needs this open source community, because there's just not enough researchers you can hire. And when you think about Llama, I sometimes reflect that Zuckerberg has a lot of researchers, but in essence, if you can get 16,000 new fine-tuned models in a month of your ship, you've got like 100,000 researchers working for you. Pretty hard to hire all those guys, which is, since you and I are big Linux people, I mean, that's the magic of Linux. You release something, you've got hundreds of thousands of people making it better. Yeah. I think the biggest things haven't changed though yet, which is for everybody, what's the safest thing I can deploy that doesn't lock me in? And how do I balance pick and choose versus already pre-integrated and running? So in some ways that has not changed, and in some ways it's gotten harder in this world. So let me just do what I would say is the most speculative part, but what are the easy on-ramps for customers and what are investors looking for? And I think for customers, I think it's hasn't really changed in the 40 years I've been working in this business, which is they want an easy on-ramp, but they don't want to get screwed with something that is going to be closed and trap them. So in other words, everyone believes the hype, but they want an easy way, and in essence, a point solution to get started. And the fact is, this huge gap between AI technology and business understanding is a problem. The terms we've been using here are all AI terms, but models and weights, I mean, this is just gobbledygook for the average human. If you didn't graduate with a PhD in AI research in the last 18 months, who understands what attention is? So that's why you've seen in this pitch a large effort to try to make this understandable for everyone. Like a CPU is like an LLM, RAM is like a context buffer. And I think those companies that make this stuff understandable are going to win. Just as a simple example, what the hell is a model? Right? As opposed to what an app is. So you can ask yourself, what is Excel for structured data? What is Word for reports? What is search to find things? And so this idea that we're just building better products, at least I found, is a great simplification. People are so relieved that we're actually making software products still. They may be engineered totally different, but they're still software products.
That's
you and I have seen this all the time. Like you and I are so excited about context buffers and tokens, and people are like, "What?
Doesn't matter."
It doesn't. It's like, what is a token? And so let's not ask customers to translate our tech talk. Let's speak in the language of customers. And they like to buy apps. They like to buy suites. They like to know they're not locked in. The last comment I'll make before we end our presentation is what investors want. I think it's pretty simple right now. It's like, show me the average recurring revenue. Because the good thing about thanks to ChatGPT is everyone's pitch is identical. I'm looking at all these pitches. I'm an angel investor. Dion, every pitch looks the same, doesn't it?
Yeah.
You can feel they're just washed through, right? This is AI, generative, blah, 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 blah.
Well, we are on the top of the hype cycle, so you're going to see a lot of noise in the signal. There's going to be a lot of AI washing and a lot of this type of stuff, probably for the first half of this year,
at least, yeah.
But yeah, before we start to see some productive light on the end of the tunnel. But yeah, we'll see a lot of that.
And for our tech people, the macroscopic reason has to do with the fact interest rates have risen. So the era of zero interest rate loans has ended. So suddenly you have to show much more immediate return. In the old days, you could buy $1 billion data center for essentially nothing. Now it costs you 11% to build $1 billion data center. By the way, for you doing the math, that's $110 million of burn every year just to fund the CapEx of the data center. Think about that startup. In the end, because AI doesn't matter, what matters is revenue. 2 million, and it's interesting how nonlinear it is. Looking at some past comparables, having $2 million of forward ARR leads to companies that are getting a $40 million valuation. If you have $10 million of ARR, you're getting an $800 million pre-money valuation. So a 5x increase in forward revenue is leading to a 20 increase in valuation because people are looking for that signal that says you're going to be able to deliver the money. Well, Dion, we finished in 1 hour, 30 minutes. We did pretty good, man. Any last comments?
No, it's really exciting. It's definitely an exciting time to be in technology. It's really cool to see that we can work on something that's not just trying to get people, to to get eyeballs on ads and to get people to shop more, but we can actually solve some real world, like deep real world problems with this technology, as what we've seen, with the skilled labor shortage that we're facing in the developed world. um I don't know where this is going to go yet, but if we just look at the amount of value that's been unlocked in such a short amount of time from this technology, I'm quite optimistic and quite bullish in this space at the moment. So let's see where
You
2024
bet.
takes us. What do you
So,
think?
so as a closing note, McKinsey published the top CEO problems that every CEO should think about. Number one was generative AI. Number two was how is technology going to change my business? And number three is how as I grow. I'd claim all three of those are the same thing. Figuring out generative AI will give you a technology advantage and let you grow faster. So the CEOs have noticed. Now we in the industry just have to deliver. Dion, thank you so much for all your time and all your hard work. It's been so great getting to know you. And this is just another example of fun sessions that we're doing.
Right. It was a good session. Thanks, Rich.
Bye bye.
Bye.